Up AP Physics 1. Today we're going to be applying our understanding of the characteristics and principles of circular motion into real life problems and using those principles that we've learned and applying that into some circular motion type questions. All right, so without further ado, let's get started. Let's get a problem up in here. So we have a problem. It asks us how fast, and specifically, I'm sorry, that was not the best way to write fast. So how fast, and they're asking it in RPMs. So how fast must a centrifuge rotate? So must a centrifuge rotate if a particle 7.00 centimeters 7.00 centimeters away from the axis of rotation. All right, so if a particle 7.00 centimeters away from the axis of rotation is another fancy way of saying center of the circle. All right, so 7.00 centimeters away from the axis of rotation is to experience an acceleration, is to have an acceleration of 125,000 G's. All right, so we need to know how fast in revolutions per minute. Let's highlight this. They want a specific unit. So how fast in revolutions per minute must a centrifuge rotate if a particle 7.00 centimeters away from the axis of rotation and another way of saying center of the circle, is accelerating at 125,000 G's. So I would encourage you to pause the video and attempt it yourself. And okay, so I assume that you paused the video and tried to attempt it, and I will move on. So this 125,000 G's, well, if you remember what a G is, you know that G is the gravitational acceleration constant, which is 9.80 meters per second squared. Some schools say that it's 10 meters per second squared, just to have a simple number. Some schools say 9.79. For the sake of this problem, we'll just say that it's 9.80 meters per second squared. All right, but your answer shouldn't be too different if you use any of the other two values. All right, so the first rule of physics: always draw a diagram. I've said that in all my videos, and I will never stop saying it. Always draw a diagram. So this circle that I'm drawing is my best representation of how the type of motion that a centrifuge goes through as it moves in a circle. And it moves incredibly fast, I must tell you. And we have a particle, I don't know, test tube, I don't know, something that moves fast to get all the heavy stuff at the bottom and all the light stuff at the top. I don't know. This is not biology. This is physics. So yeah, we have a centrifuge, and we're trying to show circular motion. We have a particle here, and let's say that this is the center, the axis of rotation, the center of the circle of this centrifuge. And they tell us that it's 7 centimeters away. This particle is 7 centimeters away from the axis of rotation. All right. And the second piece of information we know is that its acceleration, and we can make the assumption that it's centripetal acceleration because it is circular motion. Its centripetal acceleration is 125,000 G's, all right? Or another way to say it is 125,000 times 9.80 meters per second squared. Okay, that's just another way to say it. So how can we use this? Well, we know from our understanding of circular motion that centripetal acceleration is nothing but our tangential velocity squared, v tan squared, over r. All right, we know that. So let's put in the information we have. We have a radius of 7.00 centimeters, and we have an acceleration, a centripetal acceleration of 125,000 G's. So let's put that. 125,000 G's equals this tangential velocity, which is what we're trying to find. We're trying to find how fast. We're trying to find a speed. So we're trying to find our tangential velocity over a radius. Well, they gave us a radius of 7 centimeters. Let's just plug in the 7 centimeters, right? Wrong. Big no-no. And here's why. This is in centimeters. Yet, here we have an answer in meters. Remember, we're doing 125,000 times 9.80 meters per second squared. You can't have a meters here and a centimeters here. You have to have the same units throughout the whole equation. So we have to convert the 7 centimeters into meters. So in case you're not aware of how to convert it, I'll draw out a little conversion unit analysis. So we have 7 centimeters, and we have centimeters that we want to cancel out and convert to meters. So we know that 1 meter is equal to 100 centimeters. So this is just 7 over 100, 0.07 meters. All right, so we've converted our centimeters into meters, and we can plug it in because now it's perfectly legal. All right, I'll erase this little conversion chart just to show. All right, so now it just comes down to getting VTan by itself. So 0.07 meters, we'll multiply that by both sides. And we have 125,000 times 9.8, which is a number, and then we can multiply that by 0.07 meters, and we get this value to be 85,750, okay, equals VTan, or our tangential velocity, squared. So let's get the square root of this, because we just want to find our tangential velocity. We don't want to have the square of that. And we have our tangential velocity to equal the square root of 85,750, which is 292.8 meters per second. So we're done, right? We're done with the problem. Once again, no. They wanted in a specific unit of revolutions per minute. So this will be the first problem where we make that conversion. All right, and this is a very important conversion to make when it comes to physics. So the way I do it is I take this 292.8 meters per second. That means per second, you can say divided by seconds. And I want to get rid of this meters and seconds. So the way I can do that is if I want to get rid of seconds, I can put seconds on top and minutes on the bottom. And I want to get rid of meters, so I can put meters on the bottom and revolutions on the top. In that way, I can get meters to cancel and seconds to cancel. But we have to know these conversions. So we know that 1 minute is equal to 60 seconds. Hopefully, we all know that. And we have, now this one is kind of confusing. All right, this one is fairly new. Revolutions to meters. So we have to understand that if I was to take, this is a circle, circular motion, if I was to take one trip around this centrifuge, if I was a particle and I took one trip around this centrifuge, that would be the same as this circle's circumference, meaning that if I revolved around this centrifuge once, one revolution, that would be equivalent to this circle's circumference. Well, we know that circumference, and I will do this in a different color, we know that circumference is equal to pi times our diameter. You could also say 2 pi r, but I think it's a little less work if we do pi d. Okay, pi times its diameter. So obviously we have a radius here, we need a diameter, which means we have another length of 7.00 centimeters. We have 14 centimeters as our diameter, meaning we have 0.14 meters as our diameter in meters. So we have pi times 0.14. All right, so we can put that down here. So 0.14 pi. Okay, so now we've canceled out everything we need to. We're left with revolutions per meter. So now we multiply the tops and we divide it by the bottom. So we do 292.8 times 60, and we divide it by 0.14 pi. And we get a value, of 39,947. So let me write that down. We get a value of 39,947. I guess you could say 948 because it's 947.5, so 948, let's make it, revolutions per minute, RPMs. Now, this may be kind of weird to write. This may be a little bit too big to write. So another way we could write this is we could say like 3.99 times 10 to the power of 4, I believe. 1, 2, 3, 4, yeah. 3.99 times 10 to the power of 4 revolutions per minute. Both of these answers should work. It doesn't really matter. But this will be how fast a centrifuge will move in revolutions per minute if it was 7 centimeters away from the axis of rotation and had a centripetal acceleration of 125,000 Gs. Thank you for watching the video, and I hope you tune in for another one.